Hey guys, welcome to my channel. Okay, so in this video we're going to be analyzing a problem. I think it's pretty simple, and let's dive into it. It's about a quadratic function, and we need to identify the vertex and interpret the vertex. So it says the function f of t equals negative 25t squared plus 60t plus 9 describes the height in feet of a ball t seconds after it is released. Then it says find the vertex of the parabola, interpret your answer in the context of the situation. Now, first thing that I have to do is I need to identify what the vertex of the parabola is. And then after that, I need to interpret. So if I was to grade this question, I will give you 1 point for getting the correct vertex and 1 point for having the correct interpretation. So this is what you can do. You can use a formula, negative b over 2a, to find the axis of symmetry and plug that into t to find the y value for the vertex, but that takes too long. So another thing that you can do is use a calculator. So go to your calculator, go to graph, and I'm going to teach you another way in just a little bit in case you don't have a calculator with you. I'm going to teach you a different way. So you can go to the graph and plug in the equation negative 25. Because t doesn't work here, I'm going to use x, so x squared plus 60 x plus 9. So I'm going to hit enter and I get that parabola. Notice that you don't see whether you have a maximum or a minimum, so something that you can do is zoom out. So I'm going to zoom out here. Let me zoom out again. Okay, so notice that we actually have a maximum because my parabola is open down. So because my parabola is open downwards, I'm going to hit menu and I'm going to analyze graph, and because the parabola again it's open downwards, my parabola looks like this. That means that the vertex is, let me see, it looks like that. My parabola is going to have a maximum. The vertex is on the top, so therefore I have a maximum. So I'm going to hit maximum and I'm going to look for it right now. Okay, there you go. So my vertex is 1.2 comma 45. Now that is the easy part. That is the easy part of this problem. The other thing that I have to identify is I need to actually interpret what this represents. Now, if I have my axis of symmetry, sorry, not my axis of symmetry, if I have my x-axis and my y-axis, I need to know what that represents. I need to know what x represents, I need to know what y represents. So take a few seconds to think about what x and y represent in the context of this problem. Well, if you said that the x-axis or the t-axis represents time, so 1.2 seconds represent, that's what that 1.2 represents, then you're correct. And if you said that 45 represents the height, you're also correct. So a good answer for this will be the following. I can say that the ball reached its maximum height of 45 feet at 1.2 seconds. And notice how I am interpreting every single part of the vertex. I'm saying that 1.2, that represents the second, and 45 is my maximum. That's also there. And also notice that I am including units. Please do not forget to include your units. Okay? So that's it for this first part. Now let's talk about the second part of the problem. Let me move this a little bit. So we need to graph the function over a reasonable domain and range given. So I can get a few points from here, and I'm actually going to get at the vertex, I'm going to get one of the intercepts. And what else can I get? I'm going to get the y-axis. So a good way to do that is just hit Control T and go start from 0. So at 0, 0 goes to 9. Let me put this on the side. 0 goes to 9, 1 goes to 44. That's maybe over here. The vertex is 1.2 comma 45, so it's just a little bit up. 1.2 comma 45, and I know somewhere between 2 and 3 I'm going to have my my x-intercept. The graph is going to hit my x-axis. One way that I can do that is like this. I'm going to zoom in. I can zoom in, zoom, and that is one of the x-intercepts. So I'm going to get the 0, and it's 2.542 comma 0. So more or less over here, 2.542. I'm just making an estimation, so my graph is going to look like this. I know that's a pretty ugly graph, but it's going to look something like that under this domain range. Make sure that you label it. So this is the vertex, and I'm going to be very specific. I'm going to say that it's 1.2 comma 45, and this one here, the intercept. Actually, I need to mention both. This is a y-intercept, which is 0 comma 9, and I can get that from here. I can get that from this 9 here. This represents a y-intercept. Let me write that down, y-intercept. And your x-intercept is this point here, which we found that was 2.542 comma 0. X-intercept. One last thing that I'm going to ask you is that you identify the domain and the range. So domain here is not all real numbers. The ball doesn't go from negative infinity to positive infinity. It actually starts at 0. It goes from 0 all the way to 2.542. And the range goes all the way from, this is the lowest point actually, 0. That's when the ball hits the ground. And it goes all the way to 45. So that's a domain and that is a range. I will challenge you to get this for this next problem. If you don't have a calculator, then something that you can do is, and something that I do actually at home is I download the Desmos application. Let me see if I can. I download Desmos and I can plug in my equation here and get everything that I need. So I'll challenge you to do that using this application in case you don't have your calculator. And I'm going to give you the answers. So please pause the video right now and I will give you the answers in just a little bit. Okay, hopefully you paused the video, and these are the answers for both parts. Here's the first part. You can pause it to write it. And here is the second part. Make sure you pause the video so you can get the answers.